Flutter Bloc is the number one when it comes to the state management of Flutter apps. It got recently updated to have more simpler APIs to manage state across Flutter widgets. In this video, we will go through the main concepts of a block pattern by building the theme palettes app. If you are new here, don't forget to subscribe to the channel and hit the like button otherwise, and let's get started. So we are going to build a theme palette app where we have all the themes here, and then we are going to have couple colors, and whenever you click on that color it will change accordingly. And you can see also we have couple logs here, and we will discuss all of this. And then we have also the buttons. So this is mostly will be it, nothing big fancy. Mainly it's handling the logic via the Flutter block. So we create a new Flutter project, and then we put the only package that we need is called Flutter Bloc. You can pick the version, the latest version, maybe it will be different than now. So that's the only package we need to start with. Now in the main Dart app, the first thing what we need to do is bring the block observer, and then we assign it to our app observer. And that's the actually, if you want to have a high level idea about how the state is changing, you need to use this. For example, now you can see this. So whenever any state will be changed, this observer will be called, and it has a couple methods that need to be run. So we have two different IDs. So in the app observer, first we will make a class where it will extend the block observer, and then it will have the ability to access on change and on transition. The on change here can be detect. Every time we can detect if the type of the block is qubit or block base. So here you see the class block, and then here it will be block base, but because this will be can be qubit, or it only can be block. So if you don't understand what is the difference between qubit and also the block, there are a couple differences between them. For example, the block itself, it will run on the transition, not only the same as on change, because it will run in the qubit. For the block actually have a sequence of changes that call be streams, so that can be only called on a sync stream. And then while the qubit is actually, it's only asynchronous and synchronous, but not actually in a stream async. So that maybe keep in mind. So if you have a event sequence, then you might be use a block pattern. Otherwise, you will need to use a qubit. So if the qubit is changed, it will trigger on change, because we put already a condition here to make sure it's type of qubit. But the transition will be run always to check, mostly to check if that block or not. So you can see, for example, if I change here the theme, it will always run the qubit change, but it didn't run the transition because it only triggers this block. But if, for example, if I click here, then it will be the transition change, where because I'm using the block in such a case. So for now I'm using both cases, and we will see this in the home page. First we need to create qubit. So I will create, normally we create a counter qubit or theme a qubit. That's the same. The counter qubit is actually not used in such a case. I'm using a block counter anyway, but this one is just to show you the case. So normally you have a class that extends a qubit, and then the return type, and and then you create a methods here. So these methods can be, as I said, asynchronous, and then you can trigger whatever you want here, and in the end you emit the value, and the emit can be accessed because you have the qubit class here, and then you omit the value that could be an integer, depends on the type here. Now if we have the same, but now we need to return a theme data. So first it will be the same theme qubit, and then we need to instantiate it. So for example here, this will not be instantiated, and this will be throwing an error in the beginning because the qubit needs to be instantiated in the beginning. Now, when it comes to theme qubit, I created some dummy data for a couple themes that we are using here, couple color palettes, and I instantiated the one that I will show you the class of this, how we are using it. So I instantiated the one to use this, and this will be the theme, will be type of theme data. And then I created also as kind of like holding all the list of color palettes, and whenever this toggle theme is triggered, it will be triggered with the key that will be matched whatever the key inside the list of that palette, and then it will emit the value of that theme. So in the end we are returning the theme data as the same. Now when it comes to the block pattern, and then we are using a very simple example here, which is a counter. We will need to create a class, a counter event, for example, and then here it will be extended from this. So this is an abstract class, and we will extend the classes because we need to make it more readable, more regular way, let's say. So we create a class where we say increment counter and then decrement counter. These are the counter events, and then we create the counter block that will be extending block instead of qubit. We will pass the counter event abstract class, and then we will pass whatever the value we need to emit. So here we are emitting integers because it's counter again, and here, so you see the differences here inside the constructor itself. We are instantiating the on, which is that's actually what we call the sequence of the events. We're instantiating on, and we ask if whatever the type will be increment, then this will be called a callback function where we say emit the state +1. That's the same for the decrement. So whenever I hit the emit, or whenever I hit the button here, it will actually, the transition will be changed, depends on the type of event. So that's mostly the idea of the block and the qubit, and now we will go more about the color palettes that we are creating. So here it mostly is just a class when we have like name, key, and theme and main colors. The main colors will be the list of all these colors, and then we are instantiated dummy data here, and as you can see, it's more about filling all the data background. You can put more and more because you are actually returning the theme data, and it will be passed to the material app, so that you can pass everything here, depends on the theme data parameters. So now when it comes to the starter of the app, so as I said, we block, it will be observe whatever will be the app observer, and then we create our app class. This actually will be wrapped by block provider, and then we say theme qubit. So this is the first provider that we will want to wrap our all our widgets. Why? Because it needs to be around all the app, because it's a theme, so it needs to be around the material app. So in such a case, this block provider will have the create and child. The create will take the context, and then we return the theme qubit here, and then the child will take actually to the home screen. The difference is instead of saying that we want to return the material app, we will wrap it with the block builder. Why is that? Because we need to pass the themes that's coming from the builder itself to the material app. So here we say block builder. This will have the ability to see what are the qubit that we are passing and what is the returned value, and which is the theme data. This will return the material app, and then here, and we are saying just okay, bring us the page that we be surrounded by. Now I could put this all together, but I just separated to make it more easier to read. So the home content page is actually, is another block provider, but this case we will wrap it with counter provider. So let's say this is only for the home page because we need to have two buttons here, and this actually the wrapper of the scaffold itself, because the buttons will be on the scaffold. And the idea is the same. So block provider, we take the create, but the only thing we are returning a counter block instead of the others. And then we are creating the widgets itself. So this is more about the widget that needs to be built, which is the scaffold screen. And is a scaffold screen, so this is easy, I think, to follow. The scaffold will have the app bar. The body, it will be a container just to have more padding. The child will be depends on the it will be column. So, and then the children will be depends on the palettes that we have, which is the constant, or the constant value that we created in the dummy data. And we wrap it with the gesture detector, where we have the idea on when click everywhere inside these colors. The first thing that we need to do is whenever we click, we take the context and we start to read. And the read actually is that have the ability to, because now the block is actually integrated with the context, because it will be returned by the block provider, so it will be integrated. And now we have the ability to read, and then we pass whatever the type of the block that we want to return. So in such a case, I want to read the theme qubit, and then I will say toggle the theme, whatever the key I want to send, and that key will come from our theme, our palettes. So here we will pass this key, and ice cream acute will be passed this key, and so on. For this, it's more about printing on the screen what needs to be in the data. For example, we have the main colors property inside the palettes, and then we print them as a container. That's mostly is it. Now when it comes to the floating action buttons here, actually we need to have another different thing. So first of all, as I said, the context read will be injected because we have a block provider that we wrapped. Now the difference is we get a block will be passed, and then we trigger the method. And the method is actually, this will be in the top of the counter block because it's extending block. So we need to trigger add. This add is not actually defined inside the counter event. It's actually coming from the block itself. So we say add, and then we add the class where we say the event class, where we say increment counter, and the same for decrement counter here. We don't have a counter printing here, so it's not really a matter of knowing that because we can see it already, the current state and even state, but I didn't find a bit position to put here. So that's mainly it. The difference is, as I said, is that you have a sequence where you put add, and then you can decrement, or where you pass the event itself. While in the qubit you actually you have a function that actually triggering the change on the state. So I think that's mostly is it. It's a short tutorial, but to have more overview about the qubit and block pattern state management. Thank you for watching, and see you next time.